In this video, we're going to discuss how to find the value of an inverse sine function. Just as a quick reminder, the inverse sine function is defined as y equals inverse sine of x if and only if x equals sine of y, where x is between -1 to 1 inclusive of the endpoints, and y is between -π/2 and π/2 inclusive. In this example, we're going to be finding the exact value of an inverse sine function. Now this problem states, find the value of inverse sine of 1/2. If we let theta equals inverse sine of 1/2, then sine of theta equals 1/2 for -π/2 less than or equal to theta, less than or equal to π/2. Now the value of theta for which sine is 1/2 in that given interval of theta is theta equals π/6. Therefore, the inverse sine of 1/2 is equal to π/6. Now recall that there are infinitely many values of theta for which sine of theta equals 1/2, as we can note in the graph of y equals sine x. Now on the screen we have graphed the curve y equals sine x for -2π to 2π on the x-axis and -1 to 1 on the y-axis. On this graph we have highlighted the restricted version of the sine function in blue from -π/2 to π/2 on the x-axis, and we've plotted the point π/6, 1/2 that corresponds to inverse sine of 1/2 equaling π/6. In this example, we're going to be finding the exact value of an inverse sine function, and this problem states, find the value of inverse sine of the quantity -√2 divided by 2. If we let theta equal inverse sine of the quantity -√2 divided by 2, then sine of theta is equal to -√2 divided by 2 for -π/2 less than or equal to theta less than or equal to π/2. And the value of theta for which sine is -√2 divided by 2 in the given interval of theta is theta equals -π/4. Therefore, inverse sine of the quantity -√2 divided by 2 is equal to -π/4. And we can use a calculator to check this value. First, let's make sure we're in radian mode. So I hit the mode key and make sure that on our fourth line there, we've highlighted radian mode. So I'm going to do second key and mode key and quit back to the home screen. So now to calculate the value of inverse sine of the quantity -√2 divided by 2, we need to hit the inverse sine key. And notice on the sine key, above the sine key is the inverse sine function. So I'm going to need to hit the second key, then the sine key, and on my home screen I have inverse sine and a left parenthesis. So now we will hit the negative key, then the square root key, then type 2. I'm going to hit my right arrow to get out from underneath the root, and then I'm going to divide by 2 and hit my right paren. Now when I hit enter, I'm going to get a decimal value in radians of -0.7853981634. Now based on the work we did, our answer is -π/4, so this should be the decimal approximation to -π/4. So I'm going to go ahead and hit the negative key and then type pi by doing second caret key, then division and 4, and when I hit enter, I can see that I get the exact same decimal value. All right, and just for fun, right, we know that -π/4 is equivalent to -45 degrees. So if I hit the mode key and then I change to degree mode, when I do the inverse sine of the quantity -√2 divided by 2, I should get -45 as degrees. So on my calculator, I'm going to do second key, hit the enter key. That brings up the last thing I did. So I'm going to do second enter again, and that brings up the prior step, which is where I typed in inverse sine of the quantity, negative square root 2 divided by 2. So I'm going to hit enter here, and I'm going to get negative 45 since I'm in degree mode. So using a calculator is a nice way to check our work. In this example, we're finding an approximate value of an inverse sine function. And the problem states, find an approximate value of each of the following functions. Now part A is inverse sine of the quantity, negative 1/3. So we're going to take out our calculator here to get an approximation. So make sure that you're in radian mode, and we're going to hit second and the sine key, and then type the negative key, 1 divided by 3, hit my right paren, and when I hit enter, I'm going to get a decimal approximation to inverse sine of the quantity, negative 1/3, being negative 0.3398369095. So rounding to 2 decimal places, we can say inverse sine of the quantity, negative 1/3, is approximately negative 0.34. Part B asks us to find an approximate value of inverse sine of 2. So again, coming back to our calculator and typing inverse sine of 2, when I hit enter, notice the calculator gives me a domain error. Now if we stop and think for a second, I'm going to hit the number 2 to go to the error. And the calculator doesn't like the number 2 in there, and for good reason. When computing on the calculator, we get this error because there is no such angle, theta, for which sine of theta equals 2. Now as we discussed on our first slide, we were defining the inverse sine function. The domain of inverse sine is all real numbers between negative 1 and 1 inclusive of the endpoints. So therefore, the calculator returns an error because 2 is not in the domain of the inverse sine function. And therefore, we can say inverse sine of 2 is undefined.